Okay, so this is about integrating factors, which has got to be one of the silliest and coolest tricks out there. So the idea of an integrating factor is like, well, let me suppose I had a differential equation like m dx plus n dy equals 0. Right? Like, this happens. I have things like this. Suppose that the worst possible case happens, and it isn't exact. Suppose also it's not otherwise convenient. By not otherwise convenient, what I mean is like you couldn't divide through by dx and notice that it's separable or something. Right? Like, this thing's just a mess all around. So an example of something like that might be like 3x plus 2y squared dx plus 2xy dy is 0. So how do I check to see if this is exact? I probably should have done that when I wrote my notes, but I didn't. I trusted someone. How do I check to see if this is exact?
Take the y partial of the first part and the x partial of the second.
Okay, so the y partial of the first part, so my is 4y. And then take the x partial of the other part. So nx is 2y. Okay, they're not the same. This thing is not exact. Okay, so then further suppose that you had some motivation to like sort this out. Like, you wanted to blow something up, and this was the equation you needed to solve to blow that thing up. Or the king was mad that you couldn't solve this, and he was threatening to take you out back and behead you. Right? Like, these have been motivations that have really motivated applied mathematicians in the past, okay? Like, both of those things are legit. So, if you are sufficiently motivated, one of the things you might try in the being frantic phase of that would be, what if I just multiply through by something simple and then take the derivatives again? Maybe it'll work that time. Right? That seems like a really friggin' stupid plan, yeah? Okay, let's try it. What's the dumbest function you can think of? X is a dumb function that matches the category of the functions I have. If I multiply through by e to the x, which is not actually a bad idea, I'm going to end up with a bunch of product rules, right? That I'm going to have to like go sort out. X is a much like, well, it's an easy function, and I can at least take those derivatives fast and easy. What was the other dumb suggestion? I heard one suggestion that was brilliant and a kind of dumb one. 0. Yeah, you could multiply through by 0. Please note, if you multiply through by 0, you are highlighting one of the weaknesses of integrating factors in general. Don't pick the function that's identically 0. Okay? If I multiply both sides through by x, I get 3x squared plus 2xy squared dx plus 2x squared y dy is 0, right? And then what if I try my test for exactness again? What's my new my? Seems like I got a 4xy. What's your nx? 4xy. Holy shit. I literally cannot believe that worked, right? Like, the odds of that working in a not orchestrated example seem like incredibly friggin' low. You guys see that? But now I can solve this. Like, this is exact, and now I can solve it. So then the question becomes, do the solutions of that have anything to do with what you had at the beginning?
That you're showing this, I'm gonna guess yes.
Yeah, turns out they do. So, with a couple caveats. So the caveats are, don't pick things that are identically 0. Also, it's a little bit possible that things could get screwed up if you have a function that's often 0. So solutions can disappear. And also solutions can appear. Yeah. So let me give you a definition and then I'll show you where those things can come from. Okay? So I haven't really told you what an integrating factor is, right? So what is an integrating factor? Totally. Exactly the thing you multiply through by. So an integrating factor, which I'm going to abbreviate IF because I can't be trusted to spell words that long, is a function mu possibly of x and y with mu m dx plus mu n dy equals 0 exact. You guys cool with that? Okay, so the caveats are, if your m should not be, your mu function should not be identically 0, because that would be silly. If you have mu of x and y of x, like you find your solution y of x, right? And if mu of x and y of x is 0 for all x's in some interval a, b, then y will look like a solution but not actually be one. I suppose I should say may up here because they could still be a solution even if this does happen. Okay? So solutions might appear if you have a mu that has like a whole bunch of zeros all strung together. Or if mu of x and y is undefined, for y a solution, then of course it disappeared because it didn't make any sense in your exact equation. You guys see that? That kind of make sense? That said, now that I have told you about these caveats, I will probably ignore them entirely. Because the vast majority of the time this thing works just fine. Cool? Okay, let me give you a, let's see, maybe we should do this. Should we develop this or should we just give it to you? How much time do I have? None. Cool. All right, so let me then give you this thing. I never give you guys quizzes. I should give you more quizzes. So, if my minus nx over n is a function only of x, then p of x is e to the plus or minus e to the integral of that thing. dx might be an integrating factor. You guys with me on that? So if you compute these guys are the cross partials, right? So if you compute the cross partials and divide by the second function, m, if you get something that only depends on x, then if you integrate that thing with respect to x, slap it in the exponent of an e, that might be an integrating factor. Slash probably will be. Okay? I'm putting the might be in here because basically those caveats are a problem. Right? And I don't want to go through and isolate every case. So the other option is similar. And it should be noted that your book calls this case A and this one case B. So in case B, if my, it's backwards. It's nx minus my over m is a function only of y, then p of y is plus or minus e to the integral of that stuff. dy might be an integrating factor. You guys cool with that?
How do you choose when you're multiplying through, whether you use the plus or the minus?
Pick one.
Just pick one.
Yeah, I'd go with the plus one to start with.
Okay.
It'll become obvious if the signs are wrong that you screwed it up, but it won't actually matter. I'd go with the plus one all the time. Okay, so furthermore, I want to give you homework.